Good morning, friends. Today is Monday, March 8th, 2021. I hope that you had a wonderful weekend. This is Mrs. Gerhart, and I'm not feeling so hot after I got my COVID vaccine on Saturday. So, what I need you to do, if you have not already turned in your Tides gizmo to the basket, please pause, take care of that, and then return to the screencast. Additionally, you need to get the Analyzing Temp and Salinity notes from Canvas in your Oceans module, and then they should automatically embed in Cami. Again, if you need a moment to do this, please pause. So before you begin today, there is a task that I would like for you to complete. I need for you to watch the Edpuzzle video about deep ocean currents. There are no questions associated with this video, so it is truly just a watched it or you did not watch it. But the information is critical for your success in this next phase of learning. So I want you to think back, how does temperature affect density? And hopefully you're having an aha moment and you're saying, oh, that's right, this is convection. Because it is, you're absolutely correct. So remember that warmer or hot liquids or fluids are going to rise to the top because they are less dense, whereas cooler or colder liquids are going to sink to the bottom because they are more dense. 97% of the world's water is ocean water or salt water. So I want you to think, what does that do to density? Do you think that the salt water is going to be more or less dense than fresh water? Hopefully, you're saying more dense. We did cover that in notes at the end of last week. So, I want to just familiarize you with the maps that you are going to be using today. So, you are going to have two sets of maps, one for temperature and one for salinity. So, first things first, this is a temperature map, as you can see. It says it right along the top, temperature, whereas the other one will say salinity. So let's return to temperature. Let's orient you to these maps. These black areas are your continents. So here is Australia, India, Asia, Russia, North America, South America. And the things that look like the rainbow on the inside are the oceans. Notice that you have both latitude along your x-axis and longitude along your y-axis given. You will be asked about some specific areas. So for example, if I said it was 30 north, 180 east, I would be looking for the place where 30 north and 180 east crossed and they met. And you can also see that we have the various temperature colors. So we can see that the water in and around the equator here in the red is going to be significantly warmer than the water that is in dark blue at the north or south pole. Now, let's move on to salinity. Salinity is not quite as neat and tidy as temperature is. We can see that we have some areas, for example, here in the middle of the Atlantic, or just off the coast of South America, or in the Mediterranean, that are very, very salty compared to the surrounding areas. I wonder why that is. The information about the Mediterranean was included in the Edpuzzle video, so hopefully you have an answer for that one. We can also see that there are some areas, for example, here in the Bay of Bengal, where it's much, much lower salinity than the surrounding areas. Again, I wonder why that's happening. So, what you are going to do is analyze these maps following along on your lab sheet. You may work with your table partner on this assignment. Please answer the questions thoughtfully and thoroughly as you work. You are working to determine how does temperature and salinity drive our ocean currents.